All right, class. Today we will go over how to name acids.
Oh boy, I can hardly contain my excitement. Is this going to be as thrilling as watching paint dry?
Well, Jesse, I'm sure it'll be at least as entertaining as your attempts at humor. Now let's focus. Acids are an important class of hydrogen-containing compounds, and they are named in a special way. Acids were first recognized as a specific class of compounds based on their properties in solutions of water. Consequently, in chemical nomenclature, the term acid usually refers to a solution in water of one of these special compounds, rather than to the compound itself. When dissolved in water, certain molecules ionizes or breaks down in water to produce a solution containing free H plus ions and anions. The H plus ion is also known as a proton, since an electron is removed from a hydrogen atom, leaving behind a single proton. These substances, called acids, will be discussed in greater detail in a later lecture. For now, we will focus on presenting the rules for naming acids so that we can recognize these substances and name them when we see their formulas. A binary acid is a two-element compound of hydrogen and a nonmetal, usually a halogen.
Binary? Like computer code? Are we hacking now?
No, Jesse. Binary in this context means the acid contains only two elements, hydrogen and a nonmetal. Acids can be recognized by the hydrogen that appears first in the formula. An acid is a molecule in which one or more H plus ions are attached to an anion. The rules for naming acids depend on whether the anion contains oxygen. If the name of the anion ends in "ide," the acid is named with the prefix hydro and the suffix "ic." For example, when gaseous HCl is dissolved in water, it forms hydrochloric acid. Similarly, HCN and H2S dissolved in water are called hydrocyanic and hydrosulfuric acid, respectively. An acid is composed of an anion connected to enough hydrogen ions to neutralize or balance the anion's charge. For example, in HCl, the chlorine ion has a charge of 1 minus, so it will need a single hydrogen ion to create an electrically neutral molecule. Likewise, in H2S, the sulfur ion has a charge of 2 minus, so it will need 2 hydrogen ions to create an electrically neutral molecule. Even though we use names like hydrogen chloride for pure binary molecular compounds, we sometimes want to emphasize that their aqueous solutions are acids. For example, HCl ionizes into hydrogen ions and chloride ions in water. The symbol, AQ, signifies a substance in aqueous water solution. Note that both the gaseous and aqueous forms of these molecules, like hydrocyanic acid and hydrogen cyanide, are extremely toxic, so we will not be using these chemicals in the lab. The majority of acids are ternary compounds. They contain 3 different elements, hydrogen and 2 other nonmetals. If one of the nonmetals is oxygen, the acid is called an oxyacid or oxoacid. Think of oxyacids as combinations of hydrogen ions and oxyanions. The scheme for naming oxyacids is similar to that outlined for oxyanions from the previous lecture on naming ionic compounds. Many polyatomic ions are produced by the loss of hydrogen ions from oxyacids. When the anion contains oxygen, the acidic name is formed from the root name of the anion with a suffix of "ic" or "us," depending on the name of the anion. If the anion name ends in "ate," the suffix "ic" is added to the root name. For example, H2SO4 contains the sulfate anion, SO4 2-. and is called sulfuric acid. H3PO4 contains the phosphate anion, PO4 3 minus, and is called phosphoric acid. And HC2H3O2 contains the acetate ion, C2H3O2 1 minus, and is called acetic acid. If the anion has an ite ending, the ite is replaced by us. For example, H2SO3, which contains sulfite, SO3 2 minus, is named sulfurous acid, and HNO2, which contains nitrite, NO2 1 minus, is named nitrous acid. The application of these rules can be seen in the names of the acids of the oxyanions of chlorine. The acid that contains the perchlorate polyatomic ion is named perchloric acid. The acid that contains the chlorate polyatomic ion is named chloric acid. The acid that contains the chlorite polyatomic ion is named chlorous acid, and the acid that contains the hypochlorite polyatomic ion is named hypochlorous acid. The names of the most important acids are shown in the following tables. In all these acids, hydrogen atoms are bonded to oxygen atoms, not the central nonmetal atom. Often formulas are written to reflect this fact. For instance, HOCl instead of HClO, and HOClO instead of HClO2. The base name for a sulfur containing oxyacid is sulfur, instead of just sulf. The same is true for a phosphorus containing oxyacid. The base name is phosphor, instead of simply phosph. Some common laboratory acids are nitric acid, hydrochloric acid, and sulfuric acid. Acids should always be handled with care and according to instructions. They can burn holes in skin or clothing. Organic acids are also an important class of compounds, but will not be discussed in today's lesson. From the once listed acetic acid is an example of an organic acid commonly used in labs. You might be able to recognize the smell of this acid.
Yo, this smells like vinegar. It is really strong.
Careful, Jesse. This is a lot stronger than commercial vinegar, which is about 5% by volume. This acid here is higher than 5%, so extra care must be taken when you use these acids in the lab. Acetic acid is an organic acid that gives vinegar its characteristic sour taste and pungent smell. Vinegar, on the other hand, is a diluted solution of acetic acid in water. Vinegar is widely used in cooking, as a condiment, and for pickling, as well as in cleaning applications. All right, class, any questions? Let's go over a couple of examples. Jesse, why don't you start us off since you like to talk a lot? How would you name this acid?
Is it just HBr?
Not quite. Jesse, remember acids have special names depending if they are binary acids or oxyacids.
Well, how was I supposed to know that? This is like some secret code.
If you had been paying attention instead of making jokes, you might have caught on. Which type is this one?
This looks like a binary one.
That is correct. Now go ahead and follow the rules for naming binary acids.
Okay, let's see. We need to start with the word hydro, and then use the name of the non-metal anion with the ending "ik." So this compound is called hydrobromic acid.
That is correct, Jesse. Not bad for your first acid nomenclature problem. Let's try the next one, Jesse.
Mr. White, this looks very similar to the last problem.
Take a closer look, Jesse. It is different.
I see this one has oxygen in it. So is it also called hydrobromic acid?
Not quite. Jesse, remember the prefix hydro is reserved only for binary acids, and this one is an oxyacid. So try again.
So then I just drop the hydro, and it will be correct? So is it just bromic acid?
Exactly, Jesse. Looks like even you can get something right occasionally. Now let's do a few more examples. What about the next one?
Is this iodic acid?
Wrong again, Jesse. Please pay attention. What is the name of the anion?
Oh, these are the ones that have like 4 different polyatomic ions. This one has only 1 oxygen, so it is hypoiodite.
Nicely done, Jesse. Now follow the rules for naming this acid.
Okay. So the ending "ite" becomes "us." So this acid is called hypoiodous acid?
That is correct, Jesse. It can be tricky if you don't pay attention. Now, what about the next one?
Yo, are there 2 hydrogens on this one? Looks complicated.
Try to remember what I just taught Jesse.
Okay. I got this. The anion is carbonate. So we need to change the ending to "ic." So this acid is called carbonic acid.
Correct again. See what happens when you try?
See? I told you I got street smarts. I'm learning this chemistry lingo faster than I learned to sweet talk my way out of detention.
Well, Jesse, I suppose you are making some progress. Just try to apply that unique perspective of yours to actually learning the material. All right?
You got it, Mr. White? I'll have this acid name game down. It's all about that chemistry, yo.
All right, Jesse. How would you name this one?
Yo, Mr. White. Is this a trick question? There's no oxygen.
Jesse, did you hear anything I said earlier? There are 2 types of acids, binary and oxyacids.
Right, I forgot. So this is hydrophosphoric acid. Happy now?
Great job. I see you can get it right sometimes. All right, Jesse, let's switch gears and do the opposite. See if you can write the chemical formulas for some acids given the name. Start with iodic acid. What's the formula?
Aight, Mr. White. I got this. Iodic acid. That's got to be like H-I, right?
Jesse, do you see the word hydro in the name?
Nope.
That means that this is an oxyacid, so you are missing the oxygen on the anion. Now try again.
Yo, this is confusing. Okay, so like this has the ending "ik," and it does not have the prefix "per." So this has to be the polyatomic ion with 3 oxygens. Right, Mr. White?
You are on the right track. Please continue.
Okay, so the chemical formula has to be HiO3, since iodate has a charge of 1 minus. So we need 1 hydrogen ion to balance it out.
That's correct, Jesse. Well done. Here is another one. Sulfurous acid.
I'm on a roll. Let's see sulfurous. That's like when something smells bad, yeah? So it's got to be H2S, because that stuff stinks.
Pay closer attention. Jesse, there is no hydro in the name again.
Oh yeah, I knew that. So this is an oxyacid, and it has an "us" ending. So it is a polyatomic ion with the smallest number of oxygens, which is sulfite, SO3, 2 minus. So we need to add 2 hydrogen ions to the formula to balance it out. So this is H2SO3.
That's actually correct, Jesse. I have to say, I'm surprised by your progress. Let's try the next one. Phosphoric acid.
Okay, so there is no hydro in the name. So this has to be an oxyacid. The ending is "ic." So this has to be the polyatomic ion with the largest number of oxygens. So that is PO4 3 minus. That means we need 3 hydrogen ions to balance it out. So the chemical formula is H3PO4.
You got it. Nicely done. All right, here is the last one. What about hydrofluoric acid?
That one's easy. It's HF.
Well, you finally got one right without hesitation. Maybe there's hope for you after all.
Thanks for the props, Mr. White. Really feeling the love here. I think I saw gallons of this stuff in the chemical storage room. Why was it in plastic bottles? All the other acids are in glass bottles.
Jesse, you are not allowed to go into the chemical storage room. Please stay away from that room. You are correct that hydrofluoric acid is stored in plastic bottles. Hydrofluoric acid won't eat through plastic. It will, however, dissolve metal, rock, glass, and ceramics. Many of the other acids can be stored in glass bottles, except for this one. Okay, class. Any last-minute questions before we leave?
Yeah, why do we need to know this stuff? It's not like I'm going to be a chemist.
Because, Jesse, understanding the basics of chemistry is crucial for many fields, and it's part of the curriculum. Plus, knowing how to handle these compounds safely is essential. You'll use it when you need to pass this class, which at this rate seems unlikely.
You keep saying that, but I bet you don't even remember half of this stuff outside of class.
Actually, Jesse, I do. It's part of my job to know this material. Perhaps if you put in a bit more effort, you'd find it easier to remember too.
Maybe if it was more interesting, I'd care more.
Learning isn't always about entertainment, Jesse. It's about acquiring knowledge that can be useful in many ways. Remember, every piece of knowledge has the potential to be powerful in the right hands. Try to keep that in mind.
Yeah, whatever. Can we just get this over with? My lowrider's waiting.
You might be surprised, Jesse. Chemistry is everywhere, even in your beloved car. For starters, hydrochloric acid is found in your stomach. It helps you digest food.
Hold up, you telling me I got acid in my body? That's wild.
Indeed. And remember acetic acid? That's what gives vinegar its sour taste. And citric acid is found in lemons and other citrus fruits.
But what about them fancy formulas?
Good question. Knowing the formulas helps you understand the composition of substances. For instance, if you're into cars,
You know I am.
then you might be interested to know that sulfuric acid is used in car batteries.
For real? So knowing H2SO4 could help me fix my ride?
It could certainly help you understand how the battery works. And phosphoric acid, H3PO4, is used in some rust removers.
Now you're speaking my language. So this acid knowledge could help keep my car looking fresh?
Absolutely. And it's not just about cars. Understanding acids is crucial in cooking, cleaning, and even in health and beauty products. Many skincare products use alpha hydroxy acids, like glycolic acid.
All right, I see you, Mr. White. This acid game is more useful than I thought. Guess I'll start paying more attention then. Who knows? Maybe I'll end up using this stuff after all.
That's a great way to put it, Jesse. Chemistry is all around us, and understanding it can help you make better decisions in many aspects of life. All right, class, that is it for today. Please complete the homework assignment, and as always, make sure you apply yourself. This will be on the test.